I'm Kendall Giles, and this is the TechnoSlipstream podcast, where we try to better understand technologies and their impacts on society through analysis and critique. This is episode 36. Now, for those of you who are new here, the topics we discuss on this podcast typically fall under three main themes. One, understanding our socio-technical world. Two, mastering new and emerging technologies. And three, designing a future worth having. Now, in today's episode, we're going to discuss a topic that covers number one, understanding our socio-technical world. And in particular, we're going to take a look at whether or not the tech company Apple is really behind on their efforts to productize artificial intelligence. Now, before we get started, I do just want to mention that in addition to recording the podcast, I'm also recording this episode as a video. So you'll have the option of listening to the episode on your favorite podcast player, as well as watching the episode on YouTube. Now, you can find both links to both on our main website, which is TechnoSlipstream.com. But the reason I'm recording this as a video, some people like it to watch the podcast as video, so that's fine. But another reason, let's say, is that in order to address the question of whether or not Apple is behind on artificial intelligence, we're going to have to get a little technical about artificial intelligence, what it means and how it works. And so to find out really what's going on. So I'll describe everything as best I can for those who are just listening to the podcast, but you can also check out the video as well if you would like more information. So, Apple just wrapped up their worldwide developer conference. Okay, and that's where that's their annual showcase of new products and features that they're coming out with. And of course, one of the topics, subset of features and products dealt with Apple Intelligence, which is Apple's effort to incorporate artificial intelligence, across their various operating systems and devices and product lines. So that generated a lot of excitement, and they did offer lots of great things. However, as a result of their showings at WWDC 25, Apple's stock price dropped because major investors are perhaps not as happy with the level or quantity or whatever. I mean, it's a finance thing. They float with the wind, but for whatever reason, they weren't happy with Apple's offerings. And so you can see here on the left, I've got a article, snapshot from the Economic Times, and the title says, Apple stock drops 1.5% after WWDC 2025 keynote. Did Apple's big AI reveal and Siri upgrade fail to meet investors' expectations? And then over on the right-hand side of the slide, and here I'll just annotate live. On the right-hand side of the slide, I just took a snapshot. I mean, this is just the tons of YouTube videos that were made, news presentations, but you can also find articles that were written about this same theme. And the titles, I'll just read a few of the titles here so you can get a general feeling for how people think Apple is doing with artificial intelligence. The first one says, Apple falls behind in AI race. The next, will AI take Apple's crown? Next, why Apple's Siri is still so bad in the age of AI. And Apple struggles to crack AI. So that's a flavor of the sentiment out there in society for how well Apple is doing in incorporating artificial intelligence into their products, especially as compared to competitors, other large tech companies like, say, Facebook or Google or Microsoft. They feel that Apple is dropping the ball. So I thought this would be worth talking about trying to unpack what's really going on. What do we mean by AI? Why do people think Apple is falling behind? And is Apple really falling behind? So that's what we're going to try to do a deep dive on today here in the episode. Now, to kind of set the stage, right? We first need to talk about when people are talking about AI out in the world. And of course, you can't go anywhere today without having some sort of AI feature or AI product kind of shoved in your face and you're made to use. Maybe in your workplace, you're being asked to, I don't know if you're a programmer, use artificial code, bots that will help generate and write code for you. If you are a writer, perhaps it's being suggested that you use AI type chatbots, large language models to help you write better papers. If you're a student, you're probably doing this already, writing all your term papers. If you are a faculty member, you're probably using these to grade your students' AI generated papers. So it's a vicious cycle, but everybody is being told to use artificial intelligence. And I'm on the faculty in electrical and computer engineering at Virginia Tech. There's even, not in our department, but there's even a class at Virginia Tech on how to use AI, these types of large language models, these bots, to kind of do your work for you. Okay, this is in the context of management, right? So if I'm a manager and I want a project plan, I can ask the AI agent to generate me a project plan, or maybe I have a big sales presentation. I can get the AI to generate that for me, or a product pitch, or a CEO's keynote speech, that sort of thing. So we're being encouraged to use AI in almost all aspects of our lives these days, whether or not we should be. And we're going to leave that question aside, but that's what we mean by AI. And in particular, so there are lots of different types of models of AI, actually, other than these, generative AI models, these large language models. That's the generative AI and the large language models. It's typical what people are talking about. That's what all the hype is about. And so I just want to make clear, there are many, many different types of AI, machine learning models, different uses for them. But what has captured people's attention today is these large language models that generate text for us. And of course, not only can they generate text, but they can generate images. They can generate spoken word, make it sound like a person is actually talking to you. They can generate video. So this large language, when I say large language model, it applies to many different kind of forms of content that's being generated. And so I just thought it would be worth looking at one of these models in a little bit of detail so that you have an idea of, when people say large language models, many of them think it's just magic. Like, oh, it's writing this paper for us so quickly and it's so perfect, it's so well written. It's not, but people do tend to think of it as magic. So I just thought it'd be worth talking just for a little bit on how these models are actually working. Okay, so here I have on the screen a picture, and you can see the URL where this picture came from. They have an actual visual kind of synthesizer, so you can actually in real time see what's going on behind the scenes. But I just want to explain it a little bit for those, especially who are listening. So the basis of these large language models is a type of neural network. You've probably heard of artificial neural networks or deep networks, called a transformer. Okay, a transformer. And the basic idea of a transformer is you start with a prompt, right? So when you've seen these large language models used, people ask it a question. That's the prompt. It's like starting text. And so here on the screen, you can see here at the top, and I'm just annotating this on the slide for those who are just listening, but you can see someone has typed into the prompt box, data visualization empowers users to blank. Okay, that's the prompt. That's the starting text. And so what a transformer does, you can see over on the left-hand side of the model, we've got the actual words from that prompt lined up. Those are the inputs into the transformer. And over on the far right-hand side, you can see a list of possible next words, right? I mean, the prompt was data visualization empowers users to blank, right? So the purpose of the transformer is, given that input, what is determine the next word? It's going to generate the next word automatically, right? So what's actually going on? Over on the right-hand side, you can see a list of possible next words. And so when this transformer model was built, as a training data set, they made a collection of text, all sorts of different text. Basically, think of it as all text that's available on the internet. They put it all into a big pile, and that is the training data set. And in that training data set, you have all the blogs and articles and movie scripts and lots of text. So if you take all of those words that's in that training data set, you've got a dictionary of all the possible words that this model knows about, right? That's what it's trained on. So those are the possible next words that this model can choose from to finish this prompt. Okay, now in the training process, they take all of these documents and they feed it into the model, into these layers of neural networks. And they given examples of sentences in these texts, you can chop up the sentences into little pieces, and each little piece is like a starting prompt. And because they have the actual text, they know what the next word is in that actual sentence. And so they can make connections and when I say they, there's not a human making these connections. It's done through statistics. But these connections, these relationships between the words are made. Some words that commonly appear together in the training data set, they'll have strong connections. Like, Mary had a little lamb. That's going to be a strong connection because that is well represented in the training data set. But Mary had a little octopus is not well represented. So that link, that next token would have a lower weight for octopus and a really strong weight for lamb, if the starting prompt is Mary had a little, or Mary had a little blah. Okay, and so what the middle of this transformer diagram, this model, it's all of these connections between all these different words and how they appear in the training data set. Some of the connections are strong if those word relationships appear a lot in the training data set, and some of the connections are weak if those word sequences and word combinations and word relationships are not well represented in the training data set. That's what all of these little lines and connections represent in this transformer model. And I'm grossly oversimplifying it, but at a high level, the point is you have a training data set with actual text, and you use that training data set by feeding it into the model. The model will effectively learn, and I'm putting learn in air quotes, it'll learn which words appear often together and which words do not appear often together. And it's all in the end, it's all math, but that's what this model represents. And so you can see on the screen, you've got your input, prompt words, and then you've got the trained model that represents all of the likely representations. And then on the output, Well, the model, given the prompt, it has to determine what that likely next word is. And, you can imagine that for a prompt of data visualization empowers users to, there are lots of choices that could work. But there's some words that are most often more likely than others to appear. And so those will be kind of near the top of the list if you kind of rank them as a probability. Which words are more likely? They're going to be higher on the possible word output list than words that rarely ever appear. And so you can actually see the top 1, 2, 3, 4, 5 words are visualize, create, see, make, and easily. Okay, those are the top 5 words most likely to appear after data visualization empowers users to. And so what the transformer model does after ranking them, there might be a little bit of randomization involved, but it's going to pick the most likely word, which in this case is visualize. So you can see up here at the top in blue, in our little prompt box, it's generated the most likely next word. Okay, so the transformer model has added a word to the basic prompt, right? That is what a transformer model does. And that is what a large language model does. Given an input sequence, it determines the next word that it thinks is most likely. Okay, then we're not done, because you can say, well, but I've seen it generate entire stories or novels or reports. Okay, just take now this new input prompt, data visualization empowers users to visualize, okay, and feed that back into the model. And so word by word by word, the model will choose the likely next word given the input. That's all it does. That's all it does. There's no magic. There's no consciousness. There's no real intelligence. Okay? So I just want to be clear. This is what we mean when we talk about generative AI. And, it could be, this is words. It could be images. It could be pixels. It could be sound sequences. Anything can be broken down into these training bits. And the purpose of the model is to determine the most likely next bit. Okay? So that is essentially what a large language model is, as far as we're concerned here. Okay, and so is that a big deal? Certainly, it's oppressive, right? It seems magical. It seems human. Someone is. It seems intelligent, right? If we can just, with the basic input sequence, we can generate these long human-sounding words and sentences and articles and reports. Based on that really captivated the world's attention. And so you can see on the screen, I've just got 2 screenshots. The left-hand side is from Morgan Stanley. The right-hand side is from McKinsey. And the Morgan Stanley says, tapping the $6 trillion opportunity in AI. Okay, we've been working on AI machine learning for a while, but this kind of magical ability to generate stuff, generate content, captured the venture capitalist's attention. It captured the CEO's attention, right? Because, well, if I can have this little bot write articles, why do I need employees? So, venture capitalists, it caught venture capitalists' eye, it caught bankers' eye, it caught finance industry's eye. And so Morgan Stanley says some key takeaways. Artificial intelligence is poised to revolutionize online search, commerce, and content. And this burgeoning technology could help tech companies tap some $6 trillion in offline spending. And large platforms are best positioned to benefit since AI requires sizable investments in data storage, engineering, processing speeds, and more. And what that last key takeaway is referring to is, this transformer model, that we were just looking at, and I've scrolled back to it so it's not on the screen. That takes a lot of computing power. That's why you might have heard of people in the news talking about all these new data centers being built, because they have to have all these many, many thousands of computers running to make these calculations and train these models. And all of those computers generate a lot of heat, so you need tons of water to cool everything down. Got to keep everything cool, the computers melt. So these large generative AI models require tons of resources. They're very expensive to run. You got to run all these computers. They're expensive to train. Takes many, many, many long sequences of time, and takes lots of resources too. So very hard on the environment. But that's what that keynote is talking about. And then the McKinsey says the economic potential of generative AI, the next productivity frontier. And so, you might have seen breathless articles about how AI is going to devastate the workforce, the human workforce, right? If I've got all these bots that can do what people used to be able to do, they could write articles, they could do analyses of data, they could create presentations, they could create product roadmaps, they could do anything basically your employees are doing. They could write code. Why do we need so many expensive human employees? So, from a productivity standpoint, in the short term, they're thinking, well, we'll make the writers more productive because they'll be able to write articles faster, or the coders will be able to code faster by having these little bots helping out. But the end game, of course, is, well, why do we need the human coder, or the human article writer in the first place if these bots can be so productive and useful? And so here on the next slide, we've got some, this is just a section of, I was on the New York Times, and it is entered here. You can see at the top, I entered generative AI. This is just the most recent New York Times articles on generative AI. And it says Meta is creating a new AI lab to pursue superintelligence, right? The marketing and the hype is that these large language models are super intelligent. Soon we're going to have artificial general intelligence, which means we're going to have an AI that can do anything just as well, or most likely better, anything that a human can do. Artificial general intelligence. That'll be the bomb. The next article is Silicon Valley is at an inflection point. This year's hot new tool for chefs, ChatGPT, to generate new recipe ideas. I took a decision holiday and put AI in charge of my life. And the Times and Amazon announced an AI licensing deal. Okay, so this generative AI is kind of taking over the world in terms of people thinking the future will be made up of these AIs doing all the work for us. And here's a Times article on the right-hand side that says these jobs, from Forbes, says these jobs will fall first as AI takes over the workplace. Again, they're coming for your jobs. And by they, I mean the robots. And finally, at the bottom, I've got a quote from OpenAI CEO Sam Altman, who says, "We are now confident we know how to build AGI," right? If we can have large language models that are so human sounding, all we have to do is scale up these models, and soon we'll have this super intelligence. That's what's being sold to us, at least. Okay. So, let's take a step back though, right? This is the TechnoSlipstream where we a little bit more critically and intelligently look at what's actually going on. Okay, so here's an article from Goldman Sachs, who it's from June 2024, and they said Gen AI, too much spend, too little benefit. Okay, remember what's being sold is that these generative AI models will revolutionize productivity, make us so productive that we don't even need the human. But they're very expensive. And Goldman Sachs is pointing out, well, maybe, we agree they're too expensive. Where's the benefit of these models? Where's the productivity gains? Where are the useful applications? They're kind of scratching their head about that. Fortune, on May 2025, the title of the article says, sorry, let me catch up the slides here. The Fortune article says, title says, study looking at AI chatbots in 7,000 workplaces finds no significant impact on earnings or recorded hours in any occupation. Okay, so this Fortune article is talking about one of the first studies to look at AI use in conjunction with employment data. And they found generative AI's effect on time and money to be negligible. They're not useful. Okay. And one of the quotes was, AI chatbots have had no significant impact on earnings or recorded hours in any occupation. Okay. Okay. Now all of that is a lead up. Let's circle back to Apple. Okay. We know a little bit now what these generative AI models are doing, right? They're just randomly picking the next word. Yet, we've got intense hype and hysteria in the marketplace about the impact of what impact these models will have. They're going to revolutionize productivity. They're going to, you'll be able to fire all your workers. Okay, we'll just have robots doing everything for us. We'll be able to lead a life of luxury as humans. But some of that hysteria is starting to show some cracks. Okay, and we saw some of the articles from Fortune and Goldman Sachs kind of questioning that. Apple also questioned that. And remember, everybody's saying Apple is behind AI. Where are all of Apple's new AI applications and products and features? Okay, Apple has not been neglecting AI. They've actually been researching it. Okay. Let's just say they haven't bought into wholesale all of the Apple AI, all of the AI hysteria. And so just recently, they came out with a paper called The Illusion of Thinking, Understanding the Strengths and Limitations of Reasoning Models via the Lens of Problem Complexity. Okay, so this is a technical research paper. It might sound a little opaque, but this is kind of a big deal for shattering the illusion, right, of the emperor's clothes in terms of large language models. So I just want to unpack this a little bit. Okay, it's a great article. Read it if you want. But here are the main takeaways, I think. So we were talking about large language models, and I showed you the visualization of how our large language model works in terms of given an input prompt, what is the most likely next word? Okay, so I here have a bullet point on the screen. Large language models just make probabilistic decisions based on their training data. Remember, the model only knows what the most likely next word is based on the training data. It doesn't know if words weren't in the training data. Because these large language models are making probabilistic decisions, they can make errors, of course, right? Because maybe a different word was needed. Not, you don't always have the next most likely word, right? Some people are fluent and are creative, so they choose lots of options. So sometimes large language models make errors, but because people anthropomorphize these artificial intelligence models, they don't call them errors or failures. They tend to call them hallucinations because it's just like what people sometimes hallucinate and make up things. Okay, in any case, errors are called hallucinations. And why does a large language model make a particular choice? We don't know, because it's just kind of all these kind of hidden connections. Remember all those weights between all the word relationships? That's opaque to the user. We don't know why the large language model made a particular choice. It just did based on its training. So because these hallucinations are causing problems, like, I don't know, if you put one of these models in terms of driving your car and it hallucinates an obstacle and actually turns, makes the car swerve, and you actually run into a real obstacle that's out in the real world, that would be bad. So they wanted a class of models that could reason, and I'm putting reason in air quotes, right? When a mathematician reasons something or an engineer solves a particular problem, they apply reasoning and logic to, from first starting principles to get to a logical conclusion. And they can explain it, all the steps along the way. So they wanted to help smooth out the hallucinations of the large language models. They wanted reasoning models. Okay, and again, I'm doing the air quotes here. Reasoning. Large reasoning models, LRMs, instead of LLMs. And so a large language model, our large reasoning model, is designed to be self-reflective, okay? Along the sequence between all the steps that are made before a conclusion is generated, or a sequence of words are generated, it's going to tell you why it made particular choices. Okay, so if you give it a word problem, an eastbound train is traveling 25 kilometers per hour, and a westbound train, that one of these sorts of word problems, it can apply reasoning and tell you its steps, why it's making a particular conclusion. Okay, so we wanted a certain chain of steps, chain of explanations for why particular decisions are made. So that's the claim to fame of large reasoning models. They go beyond large language models to explain what's going on, make more transparent what's going on behind the scenes. Okay, fair enough. Apple decided to evaluate some of these large reasoning models, like you might have heard of Claude or O3 or DeepSeek. They've been in the news as wondrous and human-like and all-powerful. Okay, Apple said, okay, let's actually test these reasoning abilities. Are they actually intelligent? Are they showing deductive reasoning, like human reasoning, or is it only reasoning in air quotes? And so the way they did this, they did a series of experiments testing these various large reasoning models. And so they gave them some classic puzzles, like stacking blocks in a certain order. Or you might have heard of the game The Towers of Hanoi, where, and I've got a picture of a sample tower on the screen, but so let me just kind of catch up here. In the Tower of Hanoi game puzzle, you've got a series of pegs, and then you've got a series of stacked plates. And the plates are different sizes. Like in the starting sequence of plates. On the left-hand side, it's like a pyramid. So the bottom plate is wider than the middle plate, and the top plate is narrower than the middle or the bottom. Okay, so it forms a little pyramid. And the object of the game is to figure out a sequence of moves so that plate by plate, you end up with this stacked pyramid. You can only move one plate at a time, but you want to end up with that initial pyramid of plates. It's on the first peg, you want it on the third peg. So plate by plate, you move one plate at a time onto either the first plate or the middle plate or the other empty plate. And the other catch is that you can never move a larger diameter plate onto a smaller diameter plate. Okay, so that's what makes it a puzzle. And so you can see here, kind of in this middle picture, this middle state, the first peg is completely empty. The middle, so a sequence of moves has already been done, but so this is kind of in the middle of the puzzle, of solving the puzzle. The middle peg has the littlest plate and the middle plate in order, like a little mini pyramid. And then the largest plate is on the actual ending peg, the third peg. And then the target state is, well, we have the actual beginning sequence of plates replicated on that third peg. And so that's the puzzle. And so Apple asked these different models, solve it, right? Your reasoning model, your reasoning AI, solve it. And tell me how, generate an algorithm for solving this puzzle. So that's the kind of the nature of the experiment. So it's a sequence of puzzles, a wide variety of puzzles, and they tested and evaluated how well the models did at solving the puzzles. Here's the results. Okay, here's the results. Essentially, like you can imagine, it might be easy for a human or a reasoning model to solve the Tower of Hanoi problem when there are only 3 plates, right? That's not too difficult. But the problem gets more complex the more plates you have. You've only got 3 pegs, yet you have more plates to move, and you got this rule that you can never move a larger diameter plate on top of a smaller diameter plate. So it gets tricky. By adding plates, you can make the puzzles more complex. And so in their evaluation, they started with easy puzzles and made them more complex. Tried to evaluate how well the large reasoning models did. What they found was, despite some people saying we're close to AGI, when the problem complexity rises, the ability of the AI models to find a solution collapses. Okay? There's a complete collapse in the ability of the model to function, rather than maybe a more of a graceful failure, kind of as the complexity gets slightly more complex, maybe it'll take a little bit longer for the model to find a solution, or maybe, a little bit more time and effort. Beyond a certain complexity, it fails. It cannot do anything. And so that sort of failure does not scale. Reasoning does not scale like humans. You give a human a slightly more complex puzzle, it'll probably take them a little bit longer. Not a complete failure beyond a certain point. Another finding was they failed to develop generalizable problem-solving capabilities. And they even can fail when they're provided the exact algorithm solution. Like they even said, okay, here's your prompt. Follow this algorithm to solve the puzzle. if the algorithm is complex enough, the large language model or large reasoning model fails. It complete collapse. It cannot follow even the answer if it's given to it. And so in general, these models exhibited inefficient overthinking on simpler problems, like excessive compute cycles and reasoning to solve a really simple problem, and sometimes complete failures on complex ones. Okay, so the hype, what we're being sold is these large reasoning models do reasoning. Look, they can explain how they're doing things. According to the Apple paper, it's not real human reasoning. Okay, it's just air quote reasoning. They're essentially expensive pattern matchers. Okay, they're matching patterns that they found in the training data. And that makes sense based on our visual walkthrough of what a transformer model does. It's looking for patterns. That's how you train it. So of course it's going to be able to generate that. There's no magic consciousness. There's no magic intelligence. There's no magic reasoning ability that's generated out of that pattern matching. And I refer to, so the Apple paper calls it pattern matching, but there's an earlier paper from Emily Bender and some other researchers where they referred to this analogy of what large language models are doing as stochastic parrots. Okay, stochastic, randomized parrots. Parrots just kind of repeat what they hear, little bits and phrases, and they put it together. And that kind of makes sense. That makes more sense based on our understanding, at least, of what we saw when we looked at the transformer. There's nothing magic coming out of statistics. Okay? So that is what Apple found. And it's causing quite a stir, especially to the people who have been touting that we're almost at artificial general intelligence and that large reasoning models are so almost human-like and they're doing real reasoning. Apple shows that there's no reasoning, at least as far as human reasoning is going. Okay. So to kind of wrap up this deep dive, I want to ask you, based on what we uncovered here today in this deep dive, looking a little bit more closely at critically what's going on with artificial intelligence, is Apple behind in AI? Or, I'm just going to pose the question, possibly, is everyone else other than Apple caught up in AI hype? There's also in business a fear of missing out. If your competitors are investing heavily in AI, well, I better invest heavily in AI. My board of directors is going to yell at me if I don't, because everyone else is doing it. What do they know that we don't? So in business, there's a fear of missing out that drives a lot of this sort of strategy. And especially in Silicon Valley, there's a move fast and break things culture to just, hey, put the large language model in a car and see what happens. Okay. So, that's I thought that would be worth spending a few moments just to look up more deeply at what's going on with AI and Apple, because it helps us, I think, better understand our socio-technical world that we're living in. Okay. So I think that Apple showed pretty conclusively that, at least regarding the hype around large reasoning models and large language models, the emperor indeed has no clues. So what do you think? Let me know in the chat. And if you would like to see more of this type of content, then either, like the video, if you're watching this on YouTube, or subscribe to either the YouTube channel or the podcast. Maybe head over to my Patreon page, patreon.com/Kendall Giles. And I've got lots of other things there that you might find interesting if you found today's episode interesting. Okay, so thanks for listening and watching. And until next time, I will see you in the TechnoSlipstream.